On May 8th, 2014, GOES 14 was put into super rapid scan operations, meaning that we're collecting 1 minute data. So let's go ahead and look at the 1 minute visible imagery from the afternoon hours. This goes from 1755 to 1920 UTC. We're centered over Iowa and looking over southern Minnesota and eastern Nebraska over here. The first thing we'll do is mesoanalysis, look at the various boundaries and air masses that we have. First of all, you can see this boundary, which I'll draw in red here, which appears to have west-northwest winds to the west of it. We'll look at the RTMA analysis next here, but right now I just want to identify the various boundaries that we see. And then we see another one just out ahead of that right here. And then if we look over in Iowa, we see another boundary here as well. Let me go ahead and stop the loop and analyze that boundary to the east here, since that one is probably a little bit more subtle and those other boundaries further to the west. So if we go back and forth in the imagery here, we can see a line with cumulus. We see some cumulus cloud streets here within this region here, and then you have hints at enhanced cumulus such as right here, which give indications of enhanced convergence that we would have along this boundary. Meanwhile, further to the north up in Minnesota, let's go back to our fast loop here, and then we can see thunderstorms went through southwest Minnesota, moving towards the northeast and towards the north with this storm over here. And with that, we would have quite a bit of outflow behind those storms. And if we look behind those storms and look very closely here at the low-level clouds in the wake of those storms, you can see a pretty good northerly or northerly winds behind that. In other words, quite a strong push of outflow behind those thunderstorms, and you can see it again right here. And also you have some little bit of clearing within that outflow as well, which would give some indications of subsidence in the wake of some of these thunderstorms as well. So we have a lot of evidence here of outflow behind these storms, and of course, that would leave a stable air mass for later in the day. There's a moderate risk over this general area in southern Minnesota and into Iowa here, so that's why we're looking at the various storms here, looking at the various air masses and boundaries. Note this storm right here in northeast Nebraska heading towards South Dakota. It's very close to the surface low. It initiates with a thunderstorm and then moves to the north into more stable air and actually dies off here. So if we move on to our RTMA analysis, we'll stop it here at the time right around the later portion of the loop. So this is the surface temperature in yellow, and we have the surface winds. So you can see a well-defined warm front here in Minnesota, strong outflow. So this warm front is being reinforced by outflow from the area of convection that we saw in Minnesota. Surface low is down here, and we saw that thunderstorm try to get going there in extreme southeast South Dakota, move to the north into that cooler air mass and died off. And then finally, we see the various boundaries that we were looking at before further to the south. For example, right here, the cold front we can see pretty well. And then we see this wind shift. It shows up a little bit better here at the next time. So I'll go ahead and advance forward here to 21Z. And you can see southwesterly winds in the region of the dry line here with quite a bit warmer temperatures. And then remember, there was that additional boundary further to the east here, and it doesn't show up in the wind field, but we saw it in the visible imagery, and we saw indications of convergence with it, so I'll need to keep an eye on that as well. Let's go ahead to a little bit later. So what I'm going to do is just zoom in and start the loop again here. So here's the thunderstorms moving off to the northeast that we were looking at earlier. Remember, it left quite a large area in here stabilized. However, just on the southern end of that, we would have our warm front that was reinforced by that MCS outflow boundary. So on the southern end of that, where we saw those temperatures in the 70s, we would have some warm air coming in here and enough CAPE to get some thunderstorms going along that boundary here. Meanwhile, the various convergence lines that we saw, let's go ahead and stop the loop just so we can identify the various convergence lines. Remember, we had the cold front back to the west right here. We have the dry line right here with the southwest winds coming in like so. And then we have that additional boundary further to the east, which I'll draw in green here, which does have some indications of convergence along with that. As you can see, some enhanced cumulus, some convection trying to get going right here. So follow these closely here as I go back to our loop. And of interest is that easternmost convergence line that we see here. It actually intersects the warm front in Minnesota, which I'll go ahead and draw in, say approximately right in here, moving along. And as it intersects that warm front here in Minnesota that's been reinforced by that outflow boundary, at the intersection of those, you can see thunderstorms getting going here, and there were some tornado reports associated with this particular storm here. So you can see the development of that storm very nicely here in the 1 minute imagery right along that boundary. And remember, there was quite a bit of stable air to the north. So with the storm motion, keeping it along the boundary, it could still maintain that feed of warm, moist air and keep it going for at least a little while until eventually the storm motion would be further to the northeast here and take it towards a more stable air mass. So this is a good review here in terms of some of the usages of the GOES SRSO imagery. Again, that's the 1 minute imagery here. You can get a really good idea in terms of the air masses, the boundaries, where to really look for convective initiation, and then also any intersections with the various boundaries here, and giving you a better situational awareness for these severe weather situations.